1 over x plus 3, everything squared. You may encounter this problem in homework, so let's do this together. We're asked for this function to find and fully simplify the difference quotient. So now the difference quotient, we have to remember it moving forward. Okay, and can anyone refresh our memory on what is the difference quotient? Excellent, thank you very much. Well done. So it means that f of x plus h is going to be 1 over
x plus h plus 3 squared.
Very good, thank you. And then minus 1 over x plus 3 squared. Very good. The next step must be what? Finding the least common denominator. They have nothing in common, so it must be the product. Obviously, the first one gets what at the top?
X plus 3 squared.
Do we all agree with x plus 3 squared?
Why?
This denominator is this, and I have multiplied the denominator by this, and I have to multiply the numerator by the same quantity. And the second one needs exactly what it does not have. I multiply this denominator by this quantity, I have to multiply the numerator by the same quantity. So then the numerator now is x plus 3 squared minus x plus h plus 3, everything squared. So far so good? Everyone agrees with this? Yes? Is that a yes? Yes? Good, perfect. So here's what I recommend. First of all, I have a fraction at the top, and look, I also have a fraction at the denominator. Before we proceed, there are two things that I have to remember. Every time I calculate or determine or simplify the difference quotient for any function, two things must happen. What is the first thing that must happen?
Have to get rid of all h's.
All the terms without h from the numerator.
Yes.
And then the second thing that must happen, the h that right now is in the denominator must cancel out with something, simplify with something. And the final simplified form may still have h in it, and it will. But not this one. Okay, are you with me? Yes? Okay, so I'm going to write x plus 3 squared minus x plus h plus 3 squared, everything divided by, imagine that I flip 1 over h, so I'll put it in front. I should have written times 1 over h, but I put it in front. I don't recommend at this stage squaring this and then subtracting them. We can do that if you want to. But I recommend something else. And here's what I recommend. I notice that this is a perfect square, and I notice that this is a perfect square. And I would rather use the difference of squares. How do I factor a squared minus b squared? A minus b times, yes, or the other way around. A minus b times a plus b, or a plus b times a minus b. Excellent. This is the best or the easiest step. So now,
One second. The step, is that purple?
I'm sorry?
The color right before orange, is that purple?
Say that again.
Is that color purple? The step right before the orange, is that blue? Is it black? What color is that?
This is purple, I think.
Okay, so right above that, the blue one.
Right.
What is the problem itself?
This is the main fraction line where the equal symbol is. So this is the main fraction line.
Divided by
This top is this operation. This operation is this top. and this is the denominator, which is h over 1.
Okay. And then
So the top was copied, and the denominator was flipped as 1 over h, and I put the h in front.
the okay. The denominator.
I divide two fractions. I keep the fraction from the top, and I flip the bottom.
So what she's doing is dividing by h is the same as multiplying by 1 over h. That's like, she's glossing over that.
Oh, okay.
So when I divide a over b by c over d, I copy a over b and multiply by d over c. So I flip this as 1 over h. That's the property. When I divide two fractions, I multiply the top by the multiplicative inverse of the denominator.
Okay.
So that's what I did. This is h over 1, that becomes 1 over h.
Okay.
And I just put it in front, not because I didn't want to write it one more time.
Oh,
Better?
and then the next step.
The next step is I identify the fact that this is a perfect square and this is a perfect square, and I want to use the difference of squares, which is a minus b times a plus b. So the difference of squares, which is a squared minus b squared, equals a plus b times a minus b, where a is x plus 3 and b is x plus h plus 3. I just have to fill them in here. So can anyone give us the first one? Let's say the first one is with plus. What should I write?
X plus 3
Awesome.
plus
Very good.
X
No, when we have plus, we have plus. We're adding them, right? We're doing this.
plus X plus H plus 3.
Excellent. Now I have to be careful with the second one. I copy a. What is a again?
X plus 3
Very good. But now I have to distribute the negative 1 to all terms in b.
minus X minus H times 3.
This is easier, I think. Instead of squaring x plus h plus 3, because remember there are 3 terms and we have no formula, you have to do it by hand. So x plus h plus 3 times x plus h plus 3, you distribute h to all 3, h to all 3, and 3 to all 3. So you're going to get 9 terms. And then you get 3 more from the first one.
And I'll admit that's exactly what I got stuck on. Because I did the whole thing and I just didn't know what it was.
Right, because you have so many terms, you don't know what to do next. Correct. Very good. So now, still don't lose track of what we're trying to do, right? We still would like to remove all terms without h from the top. And eventually, make sure that we get rid of this one. Good. So let's combine like terms. The first factor is 2x plus h plus 6. 2x plus h plus 6. Do you agree with here this one as being 2x plus h plus 6? Now then here you're going to agree with negative x with negative x, positive 3 with negative 3, which gives us a negative h in front. And that's what I want. And then h, x plus 3 squared, x plus h plus 3 squared. And now the next step is obvious, I hope. Is it?
How
Yes.
did you get
Griffin?
rid of, why did you cross off all the ones on that orange problem? Like at the top of the screen, how did they get
This one?
disappeared? Yeah.
So you have $10 and you give it to me. Then you have $3 and then you give it to me.
Okay, I didn't realize that they were, I thought they were all negative first place.
Because, one more time, a plus b is a plus b. But a minus b is a minus x minus h minus 3. Better?
Mhm.
Good. Is this okay, everyone? So now the obvious thing is, this is what I was hoping from the very beginning, which is, that's it. That's all I wanted. So this is negative. The top is 2x plus h plus 6. Everything divided by x plus 3 squared, x plus h plus 3, everything squared. And this is final. although this is a wonderful example, I would not put something like this on a test. I think it's way too long. It took me a page, right? In a test situation, that's not. This is not the only thing I want to test. I don't want to test endurance. I want to test knowledge. But yes, you understood the steps. You understood the problem, right? Any questions here? Any questions? Yes, please.
So in my math lab, sometimes we get like really ugly fractions that are the answers, like 23 over like 2 or I don't know, just ugly weird stuff. On your test, would we get ugly weird stuff like that as the answers? Or would they
The answers could be anything, but this one, a problem like this took me, a whole page.
Yeah.
No, you're not gonna have this complicated.
Okay.
There's nothing wrong with it, but on a test situation, this is good for homework, but it's not in a test situation, no. I don't think so. Good, and next question. Very good question, Brian, thank you. Next question, anything else you would like to go back to? Anything else? Anything else? Okay, so in that case, let's go back to those limits. And I want to emphasize a couple of things before we continue. Okay, so when we talk about the limit of a function, as x approaches a number as being another number L. I said that a minute ago, but I want to write it. This means three different things. It means definitely that the limit as x approaches a from the left of f of x must be, of course, limit from x as x approaches a from the right of f of x must be L. And the other thing that this implies, or not if you want, but I need to emphasize it here, is that f of x may or may not be defined at x equals a. What does this mean? And let me give you two situations. Here's a graph and here's another. Very similar graphs. This one looks like this. And this one looks like, maybe I should write 3. I want 3. And here's the third one. And I'm going to say that this is 2 and this is 5 in all cases. I would like to know whether the limit from either side of 2 here is 5 or not. As long as the left and the right approach the same number, I don't care whether the function is defined there or not. Both sides approach the same number. Approach means approach, not equal to, right? Because I cannot make x equals 2. So can I say in the first case that limit from either side of 2 of f of x is 5? The answer is yes. That's correct. The function doesn't have to be f of x may or may not be defined at x equals a. Can I, in this case, say that the limit as x approaches 2 from either side of f of x is 5? Yes, of course. And what about here? Can I say that the limit as x approaches 2 from either side of f of x is 5?
Yes.
And what will you say about f of 2?
Equals 3.
Exactly. So the point I'm making here is this. This function is defined at that point. So what? The limit is 5. The function is not defined at that point. It's defined totally at a totally different point. So what? The limit exists as long as both sides approach the same number. And the same thing in that case where the function is not defined at 2 at all, but still the limit exists. Any questions? Any questions? Now, I would like to graph another piecewise defined function and answer some questions about limits. Is that okay with everyone?
Yes.
Okay, so let's look at 64 on page 104. And we have f of x. It is a piecewise defined function 3x minus 4 and x minus 2. The first branch for x less than 1 and the second branch for x greater than 1. And then we're asked to find some limits. So the first question is graph it. Number 1, graph f of x. Okay, what do we have to determine first when we are asked to graph a function, any function? We must find the domain always, domain. So here's what I will do. Instead of this, I will write the interval notation. How do I write the interval notation that replaces this? You don't have to cross it out. I'm just making a point. Excellent. What will you write instead of this? Very good. And now I think we have the domain clear. What is the domain of this function?
-infinity to 1, union 1.
Exactly. The function is undefined at 1. Perfect. So now we start our table of ordered pairs. Domain -infinity to infinity. I have to have 0 in the chart or table always and 1 in there. Because the function is not defined at 1, this is how I signify the function is not defined at 1. These are the parentheses from the domain. But there is nothing under 1. I cannot put any number. Nothing. Between, I know this is an overkill, but bear with me. Between -infinity and 1, can anyone tell us which function of the two are we using?
3x minus 4.
Obviously. As I mentioned, I know it's an overkill. Don't get upset. It's easier if we see it right there. And the other one for x minus 2. Perfect. What type of functions are these? Because if you say cubic, then I'll need points. If you say quadratic, I also need a few. But if you say,
Linear.
then I only need 2 for each branch, each side. Okay, so let's plug in 0 here, and please give me a number.
-2.
Uh,
Oh, I'm sorry. You're talking about the result.
That's fine.
-4.
Good. So let's plug in 1. Good. Right here inside the parenthesis. Not too far away from it, inside it. Good. So let's plug in 1 here.
-1.
Very good. And let's also plug in 2 on the other side, and we get 0. Perfect. Okay. Let's graph. From left to right, the first ordered pair, please. From left to right, the first ordered pair that I need to plot.
-1.
0
Oh.
for x,
Okay, so
-4. Very good. The next in line is
1, -1.
good. What type of point will this be? Open, very good. And we're done with the first branch, not to be extended to the other side. Perfect. So now the next ordered pair.
1, -1 again.
Yes, right here, still open, because they're both parentheses. And the next one is 2, 0, which will be, of course, a full point. And this is the graph. not to be extended to the left. Okay, so we graph the function. This is our f of x. And now we're ready to answer a few questions. Limit of f of x as x approaches 1 from the left. Limit from f of x as x approaches 1 from the left. Then as x approaches 1 from the right. And then from either side, of course. And I will add a question here. So the first one. Once you understand this table and you create it correctly, you don't really need to look at the chart, the graph. What is the limit as x approaches 1 from the left? The function values approach -1. As x approaches 1 from the right, the function values approach -1. And what is the limit from either side?
-1.
Exactly, because both sides approach the same number. One more time, is this function defined at 1? No, it's not defined at 1. It has an open point and not a full point anywhere. Any questions? Any questions? Yes.
So if we were given this problem, would we just do those 3 parts, or would we have to indicate that it's not defined at that point?
You will have to graph because the first part of
So
the
you have to
yes.
do this.
yes, that's so let me read. For exercises 51 through 68, graph each function and then find the specified limits. When necessary, state that the limit does not exist. So you will have to graph it first and then answer the limit questions. Okay, I would like to look at a graph, like for example this one. We're given this graph and we're asked to answer a few questions. So let's say problem 70. The limit of c of x as x approaches 0.2 from the left. 0.2 from the left. Let me see if I can. 0.2 from the left. What will you say? 0.2 from the left.
3.
Exactly. 3. 0.2 from the right.
3.
From the right.
Oh, 3.5.
3.5. Is that clear? So 0.2 from the left, the limit is 3. 0.2 when x approaches 0.2 from the right, the limit is 3.5. And now, of course, the final question would be from either side. Yes. What do you say? Of course. If the left-hand side is 3 and the right-hand side is 3.5, of course, the limit from either side does not exist. Very good. Any questions? Any questions? Okay, so basically, this is the end of 1.1. And the next section deals with a little bit more algebra than this one. And you can say more algebra than what we just did on the first problem. Not really. Okay, so 1.2, algebraic limits and continuity. Algebraic limits and continuity. There are certain limit laws that we will list and use. And let's start with that. Limit laws. They call them in your book properties, but they are basically limit laws. They don't exist unless the certain conditions are fulfilled. So here are the conditions, without which, if they're not fulfilled, we cannot apply the limit laws. Here is 1. Limit of f of x as x approaches a exists, which means I say equals L. When we write equals L, we mean it's a number, it exists, it's not infinity, it's not the NE. So all it says here is that the limit from the left, limit from the right are both the same, and the limit exists. Same thing for limit of another function g of x as x approaches a. Let's say this is another number. It exists, it's another number, and it's m. They can be the same, it doesn't matter. L may equal m, it does not matter. So, however, without these conditions being fulfilled, we cannot use limit laws. And what are these limit laws? Okay. So here's the first one. The limit of a sum of these functions as x approaches a. What do you think this will equal to, assuming that these two limits exist and the first one is 5 and the second one is 10? What do you think this will equal to? The limit of a sum will equal the sum of the,
Some of the limits.
exactly, common sense. So this is limit of f of x as x approaches a plus limit of g of x as x approaches a. As long as this is a number and this is a number. I want to give an example. Let's say limit as x approaches 2 from x squared plus 3x cubed. If the limit as x approaches 2 of this is a number, and the limit of this as x approaches 2 is another number, then I can use the limit law for the sum and write limit from x squared as x approaches 2 plus limit of 3x cubed as x approaches 2. But if either one is d and e or infinity, I cannot use this and I cannot split that. I cannot say that the limit, so this is not a distributive law. Do not think that I'm distributing the limit operator. No. The limit of a function plus another function is the sum of the limits. Okay. So what do you think this will equal to? As x approaches 2 from either side, which function value will x squared approach?
4.
Of course. Plus. As x approaches 2 from either side, where will the function value of 3x cubed go? Right? 2 squared, 2 cubed times 3. So the answer is 28. I was able to use this because the limit law is applicable. The limit of this is a number, the limit of this is a number, and I can split them and add them up at the end. Now here's a counterexample. By the way, let's call this 1. But what if I have minus here? What do you think? So we can cut back a little bit on writing. What do you think if I have a difference of two functions? What do you think I will have to have on the other side? Exactly the same thing, difference. Okay, so here's a counterexample. Limit of 1 over x plus x when x approaches 0. Question, can I write limit of 1 over x plus limit of x as x approaches 0 from either side?
No.
No, this is okay. What is this limit here?
0.
Perfect. So this is a number. 0 is a number, that's fine. But what about this one?
1 over 0 is not a number.
Exactly. Because we graphed, so I cannot write this. We graphed 1 over x last time. Very important graph. Let's graph it again. This is the graph of 1 over x. So then I'm asking you the limit as x approaches 0 from the left of 1 over x is?
It doesn't exist.
No, from the left. From the left. From the left of 0. As x approaches 0 from the left, the function values go negative infinity. And the limit of 1 over x as x approaches 0 from the right. Very good. Therefore, the limit of 1 over x as x approaches 0 from either side must be if the exactly. Perfect. So therefore, this limit does not fulfill the conditions of the limit law. I cannot split it into two limits. I cannot say the limit of the first plus the limit of the second. Why? Because the limit of the first one does not exist, even if the last one, the second one, has a limit of 0, which is a number. Does it make sense? So this illustrates that we have to be very careful when we attempt to apply the limit laws. We have to make sure that the conditions are fulfilled. Is this okay? Yes, Brian?
Yes, I get it. I just wanted to, so you said the two are if it's 0 or infinity, right? Those are the two where it doesn't work.
You mean if the limit is 0? 0 is a number.
0, so 0 does count.
Yes, so for example, this limit of x when x approaches 0, this is 0.
Okay.
But 1 over 0 is the problem.
One of which is.
Yes, so any number is okay, is accepted as the limit. The only thing that is not accepted, the only two things that are not accepted are infinities and DNE. So if any of those two limits of the first function or the second function, if any of them is DNE or infinity, you cannot apply the limit law. It doesn't work. There must be some other method of determining the limit, or the limit does not exist, pure and simple. Okay, next limit law. I would like you to tell me when we multiply f of x by g of x when x approaches a. What will you say? What do you think? Common sense. Of course, the two conditions have to be fulfilled. What do you think this will equal to? Oh, I should have written here L plus or minus m, right? Because we know that this is L and we know that this is m. And that's L plus or m, plus m or minus m. So this must be limit as x approaches a from it's the same idea. It's a product now. Same thing. From f of x times the limit of g of x as x approaches a. Same thing. Just common sense. The limit of the product is the product of the limits. Okay. Next one. Number 3, limit of f of x divided by g of x as x approaches a. And of course, I forgot again, L times m. Now, what do you think in this case? The limit of a ratio. What will this equal to? Of course, from either side, and the limit of g of x as x approaches a from either side. However, and of course, I forgot to write L over m. However, this one comes with a big IF. Why?
Yeah, g of x can be 0, or the limit of g of x.
Yes, exactly. Yes, so limit of g of x as x approaches a cannot be 0. Otherwise, we cannot use the limit law. Number 4, limit of a constant as x approaches a from either side. Who cares where x goes? What will be the limit of a constant? Constant itself, of course, nothing there. 5, let's say limit of the square root of f of x as x approaches a. What do you think about this one? of the limit, exactly. This will be the square root of the limit of f of x as x approaches a, of course, the square root of L. Absolutely. Well done. What do you think about number 6? Limit of a constant times f of x as x approaches a. And we had enough. I only want to mention 2 more, and I would like to look at examples.
Is it just constant times?
Of
numerator
course.
times x?
Of course, the constant goes in front because it's a factor. It's a product. X approaches a. Of course, this is c times L. So two theorems here. You can add them or consider them number 7 or number 8. Limit of a polynomial function when x approaches a, and limit of a ratio of 2 polynomials as x approaches a. But after this, we'll practice the limit laws. Okay. Now, one thing I want to refresh your memory on. Remember when we took point Q and we brought it closer and closer, closer and closer to point P, right? But it did not overlap, which means I cannot ever replace X by A because we mean approach. We don't say X equals A because we definitely don't want that. When we say X approaches A, we mean X does not equal A. So how will I find the limit of a polynomial? Now I'm going to say something that you're going to be upset about, right? Because I just said X not equal A. It turns out that for all polynomials, we can determine the limit by simply plugging it in, replacing X by A. It just turns out that it's like that. However, we still hold on to our condition. X does not equal A. Okay, what do you think this will be then? However, there is an if here. Perfect. Indeed, there are 2 polynomials, right? It's the same idea. However, there is an if here. And what is the if?
If Q of A does not equal 0.
Correct. In other words, we prefer to say this. I'm going to write that Q of A does not equal 0. That's perfect. However, we prefer to say this. If this function has A in its domain, the answer is this. If this function does not have A in its domain, which means Q of A is 0, then the answer is not this. That's exactly what you said, right? So I'll say if Q of A does not equal 0, or in other words, however, we prefer this. So limit as x approaches A from either side from P of x over Q of x is P of A over Q of A if A, the little a, is in the domain of this function. This is the rational function of this function of P of x over Q of x. Good. So we do have the concept of continuity here, but I want to stop and work on some problems together. On page 113, let's start with a polynomial, like for example, problem 14. We are given a limit, which is limit as x approaches 3 of x squared minus 4x plus 7. You can say, well, I can use a limit law here. I can say this is the limit of x squared minus the limit of 4x plus the limit of 7. True. However, what is this? It's a polynomial. I don't have to split. I don't really have to use the limit laws. Because it's a polynomial, all I have to do is just that's it. So then the answer would be 9 minus 12 plus 7. (16 minus 12 is 4. And that's the final answer. Yes, please. Right?
Actually, I was gonna ask you to scoot it so I could. get
Yes.
on that.
Yes, of course. So these are the two theorems. Maybe I should write that this is for a polynomial. And this is for a rational function. Okay, so can we continue? Okay, two very important concepts here. When finding, this is again, it's going to contradict what I just said a few minutes ago. When finding limits, we need first to plug in A. Why? Because we don't know what type of limit we are facing. So when finding limits, again, I'm contradicting what I just said many times, that x does not equal 3, which works for polynomials and rational functions if 3, in this case, is in the domain. 3 is always going to be in the domain of a polynomial function, because polynomial functions are defined everywhere. So when finding limits, we need to first plug in A in order to identify the type of limit. When we do that, we may encounter one of the two situations. One situation would be 0 over 0, and the other situation, a number, not 0, divided by 0. So two things can happen here. One situation, when I plug it in, not with a polynomial, but with a rational or other types, potentially, I can have 0 over 0 or a number over 0. 0 over 0 is called indeterminate. Indeterminate case. How is this one called? Of course. This is an undefined case. Which of these two you would think has absolutely no hope for the limit to exist? Absolutely none whatsoever. The first, exactly. Awesome. Great job. Limit will never exist. In the first case, there is hope for the limit to exist. Notice that I did not say that the limit exists. I'm only saying it's possible to exist. There is hope. The 0 over 0 can end up being 1, 5, 1500, anything. Your guess is as good as mine. But this one has only 3 options forever. One option is positive infinity. The second option is negative infinity. And we know the third possibility. The limit when x approaches 0 from 1 over x. Very good. DNE. DNE. So when we talk about limits, we say, and if they don't exist, we say positive infinity, negative infinity, or DNE. Good. So now we are ready to work on some problems, like, for example, yes, let's start with problem 22.